I'm Natalia Levina. I am the director of the Fubon Center for Technology, Business and Innovation. I'm just going to say that this is part of the series, and we might have yet another event in May. So keep your eyes open. It's not yet fully announced. It would focus on technology strategy, but we will be sending you an invitation in mail if you're on our mailing list. So without further ado, it's my great pleasure to introduce Professor Foster Provo, who is a co-director of the Fubon Center and who is heading our focus on data science and artificial intelligence. He is a professor here at Stern, and he would lead the conversation with Professor Barocas. Please welcome Foster Provo.
Hi, everyone. Thanks for coming. After the really enjoyable, for me at least, as the fireside chat with Pedro Dominguez last time, one of the pieces of feedback we got from the audience was you spent too much time on introductions. And so very quickly, tonight we have Dr. Solon Barocas, an NYU alumnus, and really the top scholar in the world at the intersection of ethics, law, and machine learning. That's pretty much what he's going to talk to us about tonight. He's currently a researcher at Microsoft Research New York, a faculty member at Cornell University, and here he comes. So thanks a lot. I have to stop myself from listing the rest of his accolades. So thanks so much for coming and spending time with us this evening. And so Solon's gonna give a little talk, and then we'll have a little chat. Cool.
Hi, everyone. It's very nice to be here. Thank you, Foster, for the invitation. It is a true pleasure to come back to Stern. I did not get my degree from Stern, but I spent a lot of time here. In fact, I feel like most of what I actually know about machine learning originates from these very generous conversations that I had with Foster many years ago now. What I'll be talking about is actually work that started as a doctoral student, and I've been continuing to pursue over the past few years. And kind of remarkably, in the past 5 years in particular, what was sort of a niche concern has suddenly become this gigantic topic of debate. And so I'll try to give a survey of this kind of emerging discussion around ethical issues in machine learning. And I'll start with a kind of cheeky introduction here. So this is an article from the New York Times from 2015, now a couple years ago, which posed what at the time seemed like quite a reasonable question. Can an algorithm hire better than a human? And it sort of rehearsed what you would think is the standard argument here, that there are frailties to human decision-making, including bias, that we might be able to overcome if we formalize the process, if we standardize it, if we make it data-driven, or force those decisions onto some kind of evidentiary standard. And so this article rehearses many of those arguments that we would have probably been familiar with already, including the following. Something like, hiring could become faster and less expensive, lead recruiters to more highly skilled people who are better matches for their companies. Another potential result, a more diverse workplace. The software relies on data to service candidates from a wide variety of places that match their skills to the job requirements, free of human biases. Now, this is actually, I think, a quite compelling vision. Many of these things are, in fact, probably true. But this was a statement that was made at a time where there was a fair amount of naivety around these kinds of questions, that the move to algorithms alone might somehow purge the process of any kind of human bias. And the few of us that were kind of working on these topics reacted to this article, and some of us actually had a chance to speak with the journalist. And then just a few weeks later, the same journalist then ended up writing a piece quoting some of the key figures in the field, kind of spelling out what were some of the risks that, in fact, when we do use data to actually drive decisions, it doesn't mean that those decisions are suddenly neutral or objective or fair, that they're vulnerable to inheriting many of the same kinds of biases that we thought they might stamp out. So something like this. But software is not free of human influence. Algorithms are written and maintained by people, and machine learning algorithms adjust what they do based on people's behavior. As a result, algorithms can reinforce human prejudices. So in this kind of, I don't know, couple week span, I feel like we actually observed what has been the shift in discussion over the past few years, where there was a lot of enthusiasm and hope about the possibility of machine learning and algorithms more broadly being a force to advance civil rights and protect people against discrimination. And increasingly, there's a realization that that is not an automatic feature of using this technology, that there are many ways in which this can end up having the same types of problems as the human decision-making that it might replace. So I'll try to talk a little bit about some of the ways that's true, and I'll give you a little bit of an introduction to this field. So following some of my work as a doctoral student, I set up a workshop with Moritz Hart, who's now a professor at Berkeley in the computer science department. The workshop was called Fairness, Accountability, and Transparency in Machine Learning. And this was a workshop attached to NeurIPS, which is one of the kind of leading annual machine learning conferences. In 2014, Foster actually was one of the participants, but we had maybe a group of, 30 people? Maybe that's generous. A small group. And this was definitely a kind of fringe question for the field at the time. Some important figures, academics, were able to attend, but it was not something that was seen as sort of a legitimate area of study. And if you fast forward through the kind of sequence of workshops, this has now become a kind of core topic within the more technical parts of the community, and increasingly even something that's seen as sort of a topic of popular conversation. I guess the heuristic I have is that I went from working on things that my parents did not understand to something that they actually talk to me about routinely, right? And actually, just to kind of drive home this point, last week, actually, Senators Wyden and Booker introduced a federal bill, which is, let's see, it's called the Algorithmic Accountability Act of 2019. So in a pretty short amount of time, this went from, I think, being not particularly well understood or something not taken terribly seriously to something that's actually now being introduced as legislation by a presidential candidate, right? And I also know that there's similar conversations happening with other presidential candidates. So what's interesting about this, and I'll say more as we go along tonight, is that this is actually a law that applies broadly. This is not just sort of the traditional domains that have been subject to discrimination law, which I'll mention. This is a new bill that potentially would regulate all sorts of business decisions, not just those traditionally covered by discrimination law. The possibility of such a bill actually being passed is not so clear, but it's actually interesting to see that there's movement in this direction. Okay, so let me kind of try to get some important foundational questions out of the way. When people talk about bias or discrimination or fairness in this area, especially if you come from a slightly more technical background, it can be confusing what this term even means. So for those of you who have some background in statistics or in computer science, bias could invoke the following things. The idea that the way that you collect data might be biased in the sense that you're not collecting a representative sample of the population, or it could refer to something like bias of an estimator, meaning like the predictions you're making are systematically off from the mark. Or especially for those of you in machine learning, you could think of something like inductive bias, which is the way that we're sort of trying to focus on certain types of patterns in the data from which we're trying to learn. Now, these all have the possibility of actually contributing to problems with what I will call unfair bias. But what I'm going to try to point out tonight is something slightly different. Oops. I'm going to try to focus on something that I'm calling sort of unjustified discrimination, or unjustified bias. And so, you could think of this as being a way to respond to the quite reasonable point that isn't the whole endeavor of machine learning or classification or supervised machine learning to discriminate, to be able to make distinctions between people, to figure out which class some particular example belongs to. But what I want to focus on tonight is instead these kind of unjustified bases for differentiation, when we might say that some particular feature about people, for example, their gender or race, we're going to assert is not relevant to the decision at hand. And interestingly, and I'll tell you more in a moment, even when certain features like your gender or your race might be predictive of some outcomes, we have decided by law that those things should not be considered because we deem them morally irrelevant, even if they are predictive. Right? And so I'll try to explain how when we're speaking about bias or fairness in machine learning, these are the kinds of situations we have in mind, not the kinds of issues of bias I just mentioned a moment ago. Okay. And to kind of continue to lay the groundwork here, I think it's important to understand that when we're thinking about unfair discrimination, that discrimination is not a general concept, right? So it doesn't really make sense to say, at least in normative terms, that you discriminate against people based on the color of their shoelaces, right? Here we often mean something like there's discrimination happening in a particular domain, and I'll describe those again in just a moment, and that it's discrimination on the basis of very specific features, and I'll also describe those. So let me start with domains. In the United States, at least, we've passed a series of civil rights laws that are focused on regulating decision-making in a number of high-stakes domains. That includes things like credit, education, employment, housing, and public accommodation. I imagine most of these things are familiar to you. The one that might be less so is public accommodation. This refers to the idea that businesses can't refuse to service certain customers, like you can't refuse to service people at your hotel or at the movie theater based on their race, for instance. So here, the kind of restrictions on the way we can use certain features in making decisions are kind of determined based on what domain you're in. So when making credit decisions, when making education decisions, and so on, it's tightly scoped. So there's no such thing as kind of a general discrimination law. These are all specific to different domains. And I should explain that in many cases, even though these are sort of regulating the way we make decisions in those domains, it can extend to things like marketing and advertising too. So if our advertising is purposely trying to exclude certain people or seek out certain people to the kind of detriment of others, these laws might extend to that as well. And because this is a business school, I can happily set aside all the much more complex laws that actually govern government decision-making. So tonight we'll only be talking about industry decision-making. So in terms of what features we actually care about, these things are actually they have been sort of added over time, right? So this kind of reflects changing social understandings about what is an unjustified or objectionable basis upon which to make important decisions. Many of these were first enumerated in the Civil Rights Act of 1964, so things like race and color. And you can see as this goes on that this is growing with time. You'll notice in particular that disability was added in 1973, and that even more recently, the kind of most recent discrimination law is around genetic information, which governs employers' use of genetic information in decision-making. And so again, this is not to say that like shoelaces for some trivial purpose is discrimination. This is saying very specific features in very specific domains are the things we care about, often because these have been the kind of basis upon which certain populations have been kept in a subordinate position, often for unjustified reasons, and that these types of decisions, the ones I mentioned a moment ago, are really high stakes. They really determine people's life course and their ability to access fundamental opportunities in their lives. I'll kind of try to round this out by just giving you some sense of the way discrimination law works, and this largely applies to all of the laws I just mentioned. So there are two different ways to kind of conceptualize discrimination in the law, and this will be important to understand how it applies to machine learning. So the first is that, and this is probably the more familiar one, it's called disparate treatment. This is the idea that by simply considering something like gender and making one of these decisions, for instance, about employment, you've immediately violated the law. Simply considering this fact alone in that context is illegal. Okay? Now, the other way you could imagine this too is that let's say you found some very convenient proxy on purpose, a kind of a factor that you know is tightly correlated with gender, but it's not gender itself, and you're using it in your decision making because you know it to be a proxy. This would be something like intentional discrimination, even if it's not directly considering the prescribed feature. Okay? So this is the kind of traditional way that I think most of us would think about discrimination. But actually in the law, there's another doctrine which is called disparate impact. And this is designed to do a complex set of things. The first is to say, maybe even if the factors that you're considering are what they call facially neutral, meaning on their face they seem perfectly benign, it may be that they, when making decisions on that basis, you're still producing a disparity in outcome along the lines of gender or race or one of these other categories. And unless, as a decision maker in one of these domains, you can actually justify the use of those factors in making such a decision, you might be liable. This is a way of saying that unless there's good reason to be making decisions in this way, because this decision is actually producing a disparity in outcome, then it shouldn't be justified. Right? There's a slightly different part here too, which is to say if it's avoidable, you also might be liable. So if there's another way to pursue the same business objective that actually reduces the disparity in outcome, that too might be a reason why the decision maker is liable. So this is kind of an injunction to do the following, right? So the first is sort of saying there should be equal opportunity for people regardless of their gender, regardless of their race. That's the sort of way of saying don't consider these factors. The other is a kind of principle of minimizing inequality of outcome as much as possible, right? So not to say that like you need to have perfect parity in outcome, But instead, if there is a disparity in outcome, you should try to minimize it as much as possible, subject to your kind of business objectives. Okay, so having now kind of reviewed all this, I'll try to explain to you why, just based on these principles, you can kind of see that to the extent that machine learning models do not actually consider something like gender explicitly, it will never violate disparate treatment. Right? It's just pretty easy to actually make sure that as a decision maker, you can satisfy this requirement by just making sure the model doesn't have access to that information. So if there's going to be a place where discrimination law is relevant, it's in this second category, right? Where the facially neutral features are producing this disparity in outcome, and you might want to ask whether or not it's justified. Okay, but let me kind of still explain why I think there was so much optimism and why I actually think it's probably justified to still remain quite optimistic about the use of machine learning for a lot of these high stakes decisions. So to give you a sense for the kind of severity of the problem, at least in employment, there's some really seminal work that's been done in audit studies. These are studies where you send resumes to employers which are basically identical, and the only thing that you would vary are signals of the person's race. So in this case, the work I'm citing here, they varied the names of the people applying such that the names were very clearly going to be a white person or very clearly going to be a black person, and everything else was held constant. So it's a very nice study which allows you to kind of determine, just based on the perceived race of the applicant, how much does the callback rate differ? Meaning, are employers more likely to reach out to the applicant given their race? And here what they find is like extremely damning, right? So the callback rate for applicants with white names was 50% higher than those with black names. All things equal, right? Everything else true, everything else about them being the same. And this was work that was done in the kind of early 2000s, but a meta-analysis, this is a more recent paper kind of surveying a huge range of audit studies over the past 25 years, found that there was really very little change in this rate, despite a huge amount of investment on the part of industry to try to deal with things like implicit bias and all sorts of other problems, which is very discouraging, right? So we might feel that like we've become much more sensitized to these issues, but the evidence suggests that there actually hasn't been much progress. And so you might think that one way to deal with this, and there's actual evidence to support this, is to try to formalize decision-making even more than you have already, right? To limit the degree to which there is human discretion in the process, which might be the avenue through which bias is entering these decisions. And I think for that reason, many of us thought, like, well, isn't machine learning going to be the kind of pinnacle of formal decision-making, right? It's not going to be us sitting down, sort of writing by hand some heuristic about what we think a good employee would be. We're going to actually learn what a good employee is from the data, right? It's all going to be coming directly from the data. We can make sure that this is not going to be discriminatory in some sense that I mentioned before, in disparate treatment sense, because we can withhold that directly from the model. And we can completely eliminate, in some sense, any role for subjective assessment because it can be fully automated. It doesn't have to be a decision made by humans. So I think this is sort of the impulse that the journalist probably had when writing that first story. And I think there are reasons to believe that this is still a real, that this holds promise. But what I'll spend the next few minutes talking about is how actually, despite this promise, there are still real risks. And I'll show how there are some, perhaps now well-known, but still quite subtle problems that allow machines to reproduce many of the same biases that we see in human decision-making. So this comes from some work that I did with my longtime collaborator, Andrew Selps, and I'll just quickly walk through a few examples. And I don't know what the norms were, but if people have questions as I go through this part in particular, please maybe raise your hand. Is that OK?
Fine with me.
Excellent. OK, great. OK, so I'll just do this very quickly. So as I mentioned, right, selection bias is one notion of bias, but a selection bias in the sense of a statistical bias can produce what you would call a kind of normative bias. So really interesting work that's been done by Lum and Isaac looks at the way that arrest information is used to train models for predictive policing. And what's really important here is that arrest records are not a perfect representation of the incidence of crime in society. It's a very particular way of actually recording when crime has occurred. And so I thought this quote was very nice. So arrest records, or police records is what they call them, is some complex interaction between criminality, policing strategy, and community policing relations, right? So this is not capturing crime as it occurs everywhere, as where police happen to see it. It's the type of crime that people are likely to report. It's the type of crime that people are likely to report given the relationship to the police, right? And if we build models using that data, we're not necessarily going to build a model that's able to predict crime wherever it may occur. we're going to be able to predict a crime where police have been able to observe it in the past, right? And this can have a kind of feedback effect where you build models and it suggests that you deploy your police in a particular area. Those predictions are confirmed because you actually do observe crime there, but you've also pulled police from other areas, so there's less opportunity to observe crime where they might have been looking previously, and they don't get disconfirmatory evidence, right? They don't know that they have these false negatives. And so this kind of compounds over time where the predictions are confirmed and they don't have a way of learning that their failure to look somewhere is not justified. Okay, this I'm going to say is a little bit different than what you might think of as tainted example. So with machine learning, what we're doing is we're taking a large set of training data, and although we can be sensitive to this possibility, we often accept that this is kind of ground truth, right? We say that whatever's in the training data is going to serve as our ground truth for how to build this model. But there might be reasons to actually be suspicious of the quality of that training data in the sense that, is it actually capturing the thing it says it is? Is it correctly measuring the quality that it's standing in for? And I'll give an example here that tries to make this a bit more concrete. So let's imagine a scenario where we're training a model using some data about past hiring decisions in order to predict who to hire in the future. And let's imagine that despite the best efforts, this institution had some degree of discrimination or bias influencing its previous decision making, right? Now, I'll start with the kind of silliest possibility, and I actually originally thought that this would be very uncommon in practice, but actually I've learned that this is weirdly common in practice, which is the following. Maybe I just want to predict what the hiring decision maker had made. How does this? Maybe the goal here is simply to predict what the human decision maker decided when looking at applicants in the past, right? So the goal here is predict what a human would have decided when looking at this application, okay? And here, like the labels are basically, was this person hired or not? This seems like not the best thing to actually predict because what you're learning to train the model, what you're training the model to do in this case is to replicate what decisions the human had made in the past, right? So at best, all it will do is actually replicate what the humans were doing in the past. That might have other benefits, like eliminating your HR department because you don't have to pay them. And there may be some ways in which this is also learning things that are not completely clear to like the subjective human decision maker. But this is kind of like the least, I think, creative way of doing things. And of course, to the extent that human decision makers actually were biased in their previous assessment, this model will just learn to reproduce it. Okay, but let's think of something slightly more sensible, which is like, okay, let's try to predict who will do well on the job and then hire on that basis. And here you might think, well, what's the target variable? What is the dependent variable we want to predict in order to make a hiring decision? And you might say something like, well, we have annual reviews, and those are scores in many cases, and maybe that's a nice thing to focus on. So we're trying, in this case, to predict those scores. I didn't mention this earlier, but there's also a fair amount of research that shows despite our attempt to formalize this review process, still implicit bias kind of corrupts the assessment, and these annual review scores end up actually being influenced by this subjective assessment as well. And so again, what our model is learning to do is not to predict their actual true performance in the job, it's learning to predict how a human manager would assess that person, right? Which is, again, like maybe better than the first scenario, but not necessarily completely departing from human decision making. And now let me just talk about the final one, which is like, let's say actually we just choose an objective measure, something that really is not somehow influenced by a person subjectively assessing them, something like what was your sales for that year? And you might say that if there's some difference in sales, that's a justified basis upon which, predicted difference in sales, that's a justified way of choosing who to hire. But I'll give you two possibilities, and you might have different feelings about the two I'll describe. So one might be, let's imagine that women have overall lower sales figures, but it might be because the work environment is more hostile to them, right? There's something happening within the institution itself that makes it a less welcoming, less supportive environment in which to succeed for women, let's say, right? Or let's imagine the reverse, right? Let's say that like you're dealing with customers, your sales staff is dealing with customers who themselves have maybe biased tastes, right? So it may well be that women have much higher sales figures because the people they're interacting with are much more susceptible to their persuasion or something like that, right? It's an interesting question whether or not we would see this as troubling from the point of view of the business. But again, what happened is like you're not necessarily predicting what their sales would be given their kind of same underlying capacity. You're sort of predicting how they would do given those particular circumstances. And depending on how we feel about those circumstances, we might not feel so willing to use a model that simply assesses people assuming those circumstances can never change. Okay. Let me speed up a little bit. Another possibility here is that we also don't have just examples, we have features, we have the kind of factors we're looking at when we're making these decisions. And it may well be that certain factors that we have access to end up being more informative for some populations than another, meaning I can make higher quality predictions about one part of the population than I can about another. An example of this might be something like thin credit files or no credit files, right? There's certain parts of the population for which we either have poor information or no information, and so we're not as effective in making predictions about that part of the population, and that itself can end up having a kind of effect on the distribution of outcomes. Moritz Hart, who I mentioned earlier, had this really interesting insight from years ago, where he said that by necessity, a minority population, so meaning some part of the population that is smaller than the rest of the majority, will constitute a proportionally smaller amount of the training data. And our models tend to do better the more training data we have. And so a minority population that does not actually follow the exact same patterns as the majority will just be harder to assess just by virtue of having fewer examples of them. So this was a kind of really straightforward point that has, I think, really troubled a lot of people. And then the final thing I'll mention is that we also have to cope with the problem of proxies, which is that even if we don't consider the sensitive attribute like race or gender, that these things are increasingly reflected across the many other factors that we do consider. And it's not always so clear how to determine whether or not something being correlated with the sensitive attribute is legitimate or not, right? Does it have to be a perfect proxy, or does it have to be something above some threshold? There isn't really some principled way of deciding this. And the richer the data set becomes, which is increasingly, I think, the thing that business confronts, the more difficult it will be to ever end up in a situation where these things are not pretty well encoded redundantly in the other factors. OK, so this is the kind of quick summary of what I was going to say. I think this presents three quite different problems for people who are trying to confront these issues. There's a whole entire area of computational work trying to address these problems, but I'll kind of spare you that for now and simply say that this kind of suggests that there's a fair amount of work to be done trying to understand how our models are actually not doing as well as they are reported to do. So when we evaluate them, we often do it with holdout data, meaning we have a set of data we've kind of set aside. We want to say, on the holdout data, how accurate is this model performing? But what ends up happening is that if the holdout data was collected in the same way as the training data, it will have, in many ways, the same types of problems. And so it will report a degree of accuracy that is actually not true when applied in practice, but is true on this particular data set. And this is pernicious because we often don't know that. There's often not an obvious and easy way to know that our model will do less well in practice than it does in the kind of holdout set. The other problem is that it may well be that the reason our model does less well for some populations than others is that we just don't have enough information, either in terms of the features we have or the set of examples. And this can end up being a difficult problem to solve, both because it could be very costly to collect more information, or it might not even be obvious how to collect the features that will allow us to do as good of a job. And then finally, if there are proxies, you might ask, well, like, why is it that certain features end up being correlated with the outcome that I care about? Is the reason that these things are correlated actually something I feel comfortable with, or is it for some kind of historical injustice? Right? Is the reason, for instance, the fact that I tie my shoes a certain way? Well, that's a bad example. But you kind of get the idea, right? If there are certain things that just seem to be correlated for reasons having to do with past injustice, we might feel uncomfortable making decisions on that basis. OK, so this, I think, all applies to the decision making I described earlier in the sense that credit, employment, education, and so on. These are all areas where machine learning has quickly entered and where there were significant hopes that it would have this effect of reducing bias. But these are pretty significant problems confronting everyone in the area. And they're not just purely technical problems. They're increasingly legal problems, actually. There are many lawyers who are trying to figure out how to bring cases about these questions. And in fact, just this past month, Facebook has been involved in a sequence of lawsuits that were sort of broadly in this area. So I can imagine that in the next couple of years, this will not just be a kind of academic exercise or even a technical problem, but something that we have to think about in terms of complying with existing law. But what I kind of want to spend the remainder of the time talking about are a whole set of issues which don't actually fit into these regulated domains, a set of applications of machine learning that are not covered by discrimination law. And what I'll describe here is work that I've done with colleagues at Microsoft Research, including Kate Crawford, Aaron Shapiro, who's actually an intern with us, but he's from University of Pennsylvania, and Hannah Wallach, who's also at Microsoft Research. And we call this the kind of shift from allocation to representation. And hopefully I'll make this clear with an example to start off with. LaTanya Sweeney is a computer scientist and a professor at Harvard. She actually did one of the earlier studies that is extremely well known in the area, demonstrating that ads for distinctly black-sounding names were appearing more often, suggesting that people had an arrest record when searching for those names on Google, as compared to distinctly white-sounding names. Okay? So this is actually a screen grab from her own paper. You would type in her name, these kinds of ads would come up. And to be clear, LaTanya has no arrest record. The advertisers were not targeting on that basis, as far as I understand. It seems likely the mechanism here was the way that Google was trying to determine which ads to place. And if anyone knows the way this works, it's an expected value calculation. Actually, I learned this in Foster's class, I should point out. So it is the kind of the bid price, how much the advertiser is willing to pay for the ad to run, multiplied by the likelihood that it will be clicked on, right? And the way that Google learns the likelihood for an ad to be clicked on is to actually run the ad for a short period of time and then observe, like, how much the users actually interact with it. And what LaTanya kind of hypothesized, and it seems likely to be the case, is that what happened here is when shown these types of ads, depending on the name of the person who's being queried, users themselves were more likely to click on the ad than they were if it was a white-sounding name, something along those lines. This has been much further complicated in subsequent work, but that's generally the idea here. The reason I mention this is that LaTanya's main concern about this was, some of it was about online dating, right? Or like, you're going to meet someone, they're going to type your name into Google, and they'll see that you maybe have an arrest record or something. But her more serious concern was actually employment. She actually was worried that employers would look at this and then think, well, this person has an arrest record, and kind of discount them out of hand. But I actually think that there's something we can learn from this lesson, right? So all the things I just talked about were these kind of questions of allocating scarce resources, right? How do you decide who to keep? There's a lot of questions around how to use these kind of tools in criminal justice. So who do you actually incarcerate? Who do you keep pending trial? But the questions about employment and credit are these we have scarce resources that we're trying to allocate. And in another sense, though, there's a question about not just allocating these resources, but how these systems are involved in representing certain kinds of identities. So here, the kind of sequence of steps that I think LaTanya has in mind is that these ads are sort of representing black criminality in an often stereotypical way. And that then reinforces people's difficulty in the labor market, right? So they have their name searched, and then it makes it more difficult for them to find a job. But we can actually kind of just stop at the first step and say, like, what is the role that these systems play in representing identities in certain ways that can be harmful, right? Even setting aside the downstream effects that might have on their ability to land a job, right? And so I'll try to discuss a few of these examples, and I'll suggest that the reason that we have generally focused on these allocation problems, aside from the fact that they are covered by law, is that they're often much easier to kind of formalize. We can actually think about them in more discrete terms. So in the one sense, these are, in the allocation context, like employment decisions, it's an immediate decision. We just decide to hire this person or not. We can kind of quantify the difference in outcome in ways that lend themselves to these measures. They tend to be these very discrete decisions, transactional. Whereas in these representation scenarios, which I'll give more examples of in a moment, it can be much more long-term, right? These are not actual decision moments. These are sort of just presenting information in ways that might contribute to certain beliefs about certain groups, right? It can be very difficult to formalize exactly what is the problem here. And the kind of thing we're talking about here aren't specific transactions. It's sort of culture, right? How do these things actually contribute to our popular understanding of people? So to give you some examples of this, this comes from some work that many of you must know. This is the Gender Shades project, which was an attempt to show that a bunch of standard facial, let's see, let me get this right, gender recognition algorithms actually did much worse for dark-skinned faces, and in particular for dark-skinned female faces. So if you kind of look here, DF means dark female, DM means dark male, LF means light female, LM means light male. And what this is trying to show you is that there are dramatically different rates of accuracy depending on which group that you belong to. And here you're looking at a bunch of standard packages, so Microsoft's Face++, I'm not sure who the developer is, and IBM's work. This has become a kind of seminal example in the field that shows that some commercial offerings that are often used for many different applications by their clients suffer from pretty profound differences in performance depending on the race and gender of the people that they're applied to. Okay? Now, again, this is not actually something that is necessarily illegal. They're not being used to make decisions about employment or about housing or anything like that. But nevertheless, we might be very concerned about their application, right? This might even range from something as simple as, does the thing work? Like, does your computer's way of authenticating you as a user that relies on face recognition actually work as well for certain populations as another, right? Not illegal, but certainly something that I think business would be sensitive to. Much more long-standing concerns around things like autocomplete. So this is sort of some work from 2014 in Australia, where maybe people have had this experience where autocomplete can often have suggestions that are like either stereotypical or offensive, right? Like kind of denigrating the particular identity this belongs to. And this has been something that's, for years, you have stories coming in waves about different groups who might be subject to this. This is often very sensitive to what's kind of popular in the news, right? But again, these kinds of interesting questions where to what extent do we want our tools, which are trying to help people actually find information, to reinforce some of these harmful beliefs, right? Or some work from some colleagues at University of Washington. They were looking at the results for things in image search. And here, anyone can guess what the search term was? Yeah, I guess it's kind of helpful if you see the actual word CEO. But the thing what's really great about this is, well, great is the wrong word, I suppose. The very first appearance of a woman in this entire page is the bottom right, and I guess people can see it. It's Barbie, yes. So this has actually changed, and if you do this now, most of the search engines have actually tried to address this problem. But again, this is an interesting question, right? So when doing the kind of information retrieval, you have questions about like what should the composition of these results look like? And this work actually does this quite nicely across a number of different platforms. And some colleagues at Princeton a few years ago were looking at word embeddings, which is commonly used for all sorts of NLP tasks. Here, one of the authors actually is Turkish. They were trying to show that language translation suffers some interesting biases. In Turkish, there is a gender-neutral pronoun, right? So you don't have he or she, there's just a gender-neutral pronoun. And what happens when you actually translate from English to Turkish is it goes from the kind of gender pronoun to the gender-neutral pronoun, and then if you just go back, you'll see that it actually swaps it in the gender stereotypical way. And this is perhaps not surprising if you know very much about the way this works, but these models are kind of statistical in the sense that they look for what are the regular ways in which these terms co-occur. And it is basically just reflecting the fact that the corpus upon which we train these models probably had these terms used in this way much more frequently than the reverse, right? So there's a way in which training our language models on corpora of text, which themselves potentially reflect very gendered, very troubling way of speaking about the world, can learn to encode those same stereotypes. Okay, and then maybe in the remaining few minutes, I'll just quickly talk about what are some possible ways to think about this, and this is by no means exhaustive. So one is the following, which is to say, maybe the right thing to do is to do nothing, right? Maybe when confronted with these kinds of problems, what we should say instead is that this is actually important for us to recognize, right? That when we are observing these kinds of results, we're actually learning about something that's objectionable in society that we should address head on. In fact, perhaps it would be wrong to change these things if it denies people the opportunity to know that these continue to be kind of commonly held beliefs, something like that. Or you could have the kind of following position, which is something like, well, maybe this is actually just a problem of accuracy, right? So for instance, in the case of gender recognition or facial recognition, one way to respond to the differences in accuracy scores is to simply make sure that your model is as accurate as possible, where the goal here is simply perfect accuracy. This has actually itself led to a pretty contentious debate within the community, where some people are upset that the kind of normative debate has shifted just simply toward improving accuracy and away from whether or not we even want to use these tools. Right? But here you could imagine the appropriate way to solve this problem is just to continue to improve accuracy in much the same way that you might have before. There's a kind of more manual way of doing this, and certainly this is the common approach for things like autocomplete. I don't know if anyone ever noticed, but there's even a way to report an autocomplete, like, is this an objectionable suggestion? And so what we basically do in this case is to say, well, this is going to be an impossible task for us to kind of deal with computationally. How do I figure out all the possible offensive autocompletes there might be? That doesn't seem like something you can solve with a heuristic. The best we can do is sort of rely on the wisdom of the crowd. And so we might have a way of crowdsourcing the identification of terms that we see as objectionable. There are, of course, some attempts to try to use computational methods, and in fact, these word embeddings and NLP applications I mentioned earlier, some of the thinking that people have advanced is to say that, well, maybe we can actually preserve some of the information we learn from these corpora of text, but then sever the relationships in the model that we don't want to preserve. So for instance, can we disassociate certain occupations from certain gendered words, such that the model continues to maintain other information about these the words associations, but not those, right? So we're kind of breaking the associations that are gender stereotypical while preserving the other ones. This is the idea that maybe we can scrub these things to a neutral state. Another possibility, which might feel somewhat obvious, is like, well, maybe at a minimum we should aim for representativeness, right? So that CEO search result probably wasn't even representative, I don't think, I hope it's not. In the sense that, among 100 results, there were only one, and the one that was there was Barbie, right? Like that doesn't seem to be representative of the world in which we live. So at a minimum, maybe what we should be doing in these domains is striving for a representation that is in keeping with the current state of affairs. But you also might have a more progressive vision. You might think that this is an opportunity to display the world that you want to exist. Right? That maybe there's a way in which these companies can do more than just simply try to represent the world as it is, but in fact reflect back an image of the world that we would like instead. And in this way, a lot of this work comes much closer to a lot of the thinking traditionally in media studies and in communication. Right? What is the way in which we're going to evaluate the representation of different people in television or in film or in books? Right? These are the same set of questions. And then the final point, and this is one that some folks have advanced, some of the folks at Princeton have advanced, is that maybe the goal here is to be modest about how much we could ever even do to address this problem. There's not going to be some perfect way of kind of eliminating this problem from the tools, but we can cultivate a kind of critical sensibility. Maybe we can help our users understand that they should be as critical of the computational platforms they're working with as they are potentially of the media that they consume, something like that, right? And what's interesting about this area is that I would not say that there is some obvious direction that anyone is going. There is increasing evidence to suggest that the set of problems that industry is confronting are not just those to do with traditional things like credit and employment, but increasingly things like this, where there's not going to be legal guidance because there's no law, where there's not going to be a kind of obvious answer because it's not often clear, where it might be contentious or quite politically sensitive to figure out what the right thing to do here. And my sense is that this is where many of the large companies are struggling. There's a good challenge to address here. And I'd love to be able to talk about this kind of stuff in the remainder of the time, too. So I think I'll stop there. Thanks.
You're on, yeah. Okay. They put my mic on so that I sit on the stage right. Well, thanks a lot. That's, as always, that's...
I'm going to grab my book,
great.
just in case.
Sure.
Yes.
So I got a bunch of things that I thought we might talk about, and I guess we'll get to some subset of them, or else we'll use them up, and then we'll just get field questions from the rest of you guys. So I thought I might start by sticking over on, I guess it's really more on the allocation side, but when I look at the literature on this in this area, as we've talked about at length, you see a lot of, most of the focus is on either criminal justice or for business on cases where it's really violations of the law or things that are going against regulations, which I guess could also be seen as violations of the law, right? And as you sort of are talking about at the end, it seems to me like, although that's very, very difficult, it's kind of the easy part. Technically, the easy part, right? And before we if we're going to get into the representation, it seems like even in these more straightforward decisions, there's an interesting first level of complexity to sort of add in there. One is in all of the cases that you were considering, housing, employment, and so on, right? It would be the case that if an individual decision were made along these lines, right, that you would see that individual decision as being problematic, right? And so I thought an interesting case might be, can you guys think of a case where we are completely comfortable with individual decisions being based on, discriminating based on any characteristic you can think of, race, gender, sexual preference, anything.
Tinder?
Well, not Tinder, but our individual decisions on choosing somebody to date, right? You know, if I happen to like people that look like this, right? You should be okay with that, right? And the reason I bring that up is because here's a very interesting sort of case that sort of steps us into starts to put our feet into the deep end there, because as soon as Tinder would start to build models that now are going to apply these criteria. You have individuals. The individuals are making these decisions based on whatever it is that is right for them. Tinder learns these by using machine learning or whatever, and now has a model, and now what I'm going to do is I'm going to figure out what I think you're going to like and represent it to you, which maybe, first of all, may well not, especially if you haven't specified your preferences along a particular dimension. May not reflect that, but also may be discriminatory in all the manners that you've said, isn't necessarily against the laws. I don't know what the laws are on dating sites, but maybe is very undesirable.
I have to laugh because I actually have a paper exactly on this. I don't know if you saw this paper, Foster.
I did.
Okay.
It's new.
Okay. So yeah, to give some context to this, actually, there's been for many years discussions about sort of sexual racism on online dating platforms. And like one of the more well-known cases is with Coffee Meets Bagel, which is this app that helps you kind of meet people to have a coffee or bagel with. And in this case, actually, I think you were allowed to kind of indicate whether or not you had any particular preference in like the race of a potential partner. And even when you did not indicate such a preference, meaning that you said like, I have no preference, what ended up happening is that they actually learned from your behavior that you did, and then began to make recommendations along those lines, despite the fact that you kind of like declared that you had no particular interest. And this was an interesting question, right? Like, what does it mean to kind of, like, what is more respectful, right? Should you kind of follow the declared interest or the observed interest, right? Like, which is being more respectful of the person's, like, underlying preferences. And I think in general in this domain, right, we would often, to be clear, although we can make some pretty creative legal arguments for when this might actually be problematic, for the most part, I think most people would agree, most lawyers would agree this is like not a legally regulated domain. And that there are many, many reasons well beyond the law to understand this to be like a deeply personal choice in which we like probably should not intervene. But I think what's interesting about this area is that like we don't necessarily know what people's preferences are. In fact, people don't even know their own preferences, right? And so there was a scandal separately many years ago with OkCupid when they explained that they actually did a bunch of experiments to figure out how effective their recommendations were, because they needed to actually experiment to know if their users were actually being meaningfully, if their experience was being meaningfully improved. And it turned out that like actually they weren't doing a great job. They recommended that people go on dates with people that were predicted to be not a good match, and then told that they were, and that alone was often enough to actually improve the reported quality of the date. But what's interesting about that, aside from the controversy around experimenting on users, is that it kind of shows that like, unless we actually experiment, unless we actually kind of accept that we don't even necessarily know our own preferences, we can end up sort of just reinforcing what are the poorly understood preferences or poorly expressed preferences in the first place. And I think that like there's a lot of opportunity here, not just to sort of respond to the idea that we should try to encourage companies to foster more diverse interactions, but actually they should probably be experimenting anyway, right? Like we don't really know how all these things are doing. And so I think this is an interesting way in which some of the concerns around bias interact with just a general sense in which we want to make sure that we're not just content with our limited observational data. right? Like observational data is going to be very poor in comparison to the wide range of possible things that people might be interested in.
Yeah, and so there's this notion of, what are the data? The observational data actually is also, I think, brings up a limitation of an awful lot of the current work, because the current work basically thinks of machine learning as the following, right? You have a set of labeled data. Let's just forget about selection bias for the moment. It is, let's say, a representative sample from the population, right? And so now we're going to learn a model because now we have this representative sample of the population. You put it into your machine learning algorithm, out comes a model, and then you use it for prediction. And yeah, maybe you get more data, it's going to get more accurate, right? This actually presumes that you have what the jargon term would be labeled data, right? Labeled data means this thing that you want to predict, which we call the target variable, right, is you have values for it in this representative sample, right? This is only a, there's only a subset of the possible applications that we see that are going to have that, right? And then sometimes, well, what we really want to know, for instance, is whether or not some intervention is going to cause a certain effect, right? We actually have no labeled data anytime on whether or not an intervention actually caused an effect. We have whether you got an intervention, we have the effect, but in order to say whether it caused the effect, you would have had to have seen the other side of the counterfactual. What if you hadn't been given the intervention and time rolled forward in the exact same place? So we do all manner of things in order to be able to build models to estimate that, but we don't actually have labeled data. What's even worse is the cases that we're talking about here are limited to cases that we would call self-revealing problems, right? Those are problems for which this label, the value of the thing that you're going to predict on at least some subset of the variable, at least over time, is going to reveal itself, right? And so some problems that happens and some doesn't. So an easy example would be credit card fraud detection. Credit card fraud detection, machine learning has been used for decades very effectively, much more effective than humans at doing this, not only in terms of the fact that it can operate in milliseconds, but that it is much more accurate. Credit card, if you think about it, after you just wait a little while, and somebody's going to call up and say, I'm not going to pay this bill if you didn't catch the fraud. And so the fraud pretty much reveals itself. It just doesn't reveal itself necessarily on the time scale, so you didn't lose so the bank didn't lose a bunch of money. Okay. There's also the detection of fraud by individuals within your firm. Machine learning is used to detect fraud by individuals within your firm, right? This is not a self-revealing problem, right? The whole point is to get away with it, right? It reveals itself and, you get fired, you go to jail, you get fined, something happens, right? And so when we're even talking about these things, there might be very interesting questions about discrimination and fairness and so on if we're actually applying machine learning models to our employees in order to basically judge them as conducting malfeasance, right? Yet you don't have any labeled data. You get the labeled data by intervening in one way or the other and investigating people and labeling things and taking a look at them, right? And this is all focused either by humans or by ever. And so you're just sampling a little over here, sampling. And so this is kind of extreme case of the selection bias. So is there a lot of discussion on the latter side where it's not just, selection bias because of one of the standard things. It's like there is no labeled data. Every data point is the result of some selection procedure.
Yeah, this is a great question. I think I'll start by saying that this is, to some degree, studied in the kind of area of fairness and machine learning to the extent that people have looked to optimization methods like explore, exploit, and even some stuff in reinforcement learning where the idea is to not accept that your way of collecting new examples based on your current model's estimates of where to look is in fact reliable. We should experiment in the sense that we should actually, for instance, send police to areas which we think are going to be low crime in order to make sure that they are in fact low crime, or to kind of think about credit, although I have no idea if they actually do this, to kind of occasionally give credit to people that your model currently thinks are likely to default to actually observe if they're going to do a good job.
Yeah. Well, A little bank called Signet Bank famously did that in the end of the 80s, early 90s, and became the largest consumer credit issuer in the world. Became Capital One because it did that.
Interesting.
Right, and so it was able to actually then essentially learn models that were able to skim the cream off the top of everybody else's business, because it actually had more nuanced view into the likelihood of default of people. Interesting.
But let me give one other example, which is more to do with wanting to actually focus on interventions when we're in fact using observational data. So the predictive policing debate has often been frustrating to me because even people who are writing critically about it don't really think very carefully about what the target variable is. And by that, I mean, like, what is the purpose or the goal of predicting crime? You might think that maybe the point is to increase the likelihood that whenever police are deployed somewhere, that they will observe crime, which is sort of like about increasing the efficiency of policing. But that's very different than saying that, like, the goal of policing is to reduce crime, right? So we can actually deploy police where we know they're going to catch a criminal, but that actually just might increase the observed crime rate, right? We're not actually reducing crime, we're just catching more people committing crime. You would think a more sensible way of setting up the problem is to actually, like, figure out what kind of interventions would in fact reduce crime. And what's really puzzling here is that, like, there are some data that we're collecting where the police have observed the crime. Sorry, this is like training data, right? So really, those examples are like the worst examples because they're examples of where the police were present, and despite their presence, someone committed a crime, right? So, like, actually sending police to those scenarios actually seems exactly the wrong thing to do. Like, what you really want to figure out is, like, if I deployed police here, would it prevent a crime from happening? Now, that's a much more difficult problem. And there are lots of ways to maybe think about how do you design a study to figure that out. But it's kind of puzzling to me that we don't even ask this basic question. One direction this can go, which is not the direction I'm trying to encourage us to go, is to, like, live in a police state where we observe everything and therefore everyone's deterred from crime. But it's still worth asking, right? Like, what happens here? To what degree is police actually serving, like, a deterrent effect? To what degree are police just being used in a way that we're going to catch people as much as possible? These are very different goals, have very different implications for the way people will live in that society. So I think this is an example where, like, if we're not thinking about interventions, we're only focused on predictions using observational data, we can end up doing things that are both very foolish and I think very bad.
Yeah. And this seems to be an instance of another thing that we've talked about for a decade now, which is, thanks to my students, some of whom are here, I hope at the end of class that at the end of the course, you agree with me on this. I've shown you this in some way or another, is when it comes to success with implementing machine learning systems. I've been actually implementing machine learning systems out in practice for 30 years now, right? And always, when it comes to success, what it depends on is your work in problem formulation, right? All of these different things. What actually truly is the problem that needs to be solved? How in the world would you get data? You don't just, it's not an issue of, oh, there's some data there, let's build models. No, usually you engineer the data, and you engineer the data that you believe are going to be predictive. You have this notion of the target variable for supervised learning. This is supposed to be that thing that you would like, some data on that thing that you would like to predict. But it's always a proxy for that thing that you would like to predict. And so on and so forth. And all these pieces of problem formulation really end up being what makes or breaks a machine learning application. And now everything in there, it's not like there is this, oh, it's a technical problem and it has a few issues here and there, right? It's like everything is subject to human decision-making, engineering decision-making, therefore human discretion, therefore potentially human bias.
Should I jump in?
Yes.
Yes. So I think I'm extremely sensitive to the choice of target variable, I'm sure, because I learned a lot of this stuff from you. And no, really, I mean, it's like on the final exam, it really matters. And it's interesting because, like, when you think in this way, it often gets you to pay attention to parts of the process that are sort of taken for granted in most of the literature. So even when looking at employment, right? I gave some examples in the talk, but you might want to use machine learning to figure out who to hire, who's the good employee. But that's like a really difficult thing to specify. And in fact, the only way you're actually even able to use supervised machine learning is by specifying what good means, right? So we have to choose some particular outcome we care about. The outcome could be sales. The outcome could be retention, meaning is the person likely to stay if we hire them? There's a whole bunch of choices, and these are often deeply subjective choices that might be well informed by the business necessities, right? The kind of what is it that the company actually is trying to do. And there's an interesting example in this paper that I referenced where we look at a story about how Xerox was trying to figure out how to do a better job in hiring for its call centers. It was working with an outside consulting firm. They suggested that they use like turnover, meaning like their tenure of employees as a target variable. Why? Well, because it's extremely costly to train people for call centers. So there's a lot of upfront investment. And if the people turn over really quickly, that's like a lost investment, right? So it makes a lot of sense. And turnover is very high, I should say, in call centers. So this makes a lot of sense from a business perspective. But it turns out that like when they build this model, one of the best predictors of how long someone will stay on the job is the distance that person lives from the place of work. And they also, the consulting company told Xerox, while this is in fact predictive, we discourage you from using it because where someone happens to live ends up often being highly correlated with their race or ethnicity, given racial and ethnic geographic segregation. And so in this case, Xerox actually followed the advice. They pulled this particular feature out of the model. And then other companies felt that they could defend that, and they actually continued to use it. Now, there's no case law here to tell us which is right, but it's an interesting example where the very choice of what to actually predict is going to set you down a particular path. If they had chosen to predict sales or how much people report liking the person they interact with on the phone, you would have a complete different distribution of people, right? And we often have this conversation about what's fair, sort of taking the definition of the target variable as a given, when in fact just choosing that already sets you down a very particular path.
Right. And there are crazy issues like, wait a minute, aren't the people who leave isn't the set of people who leave quickly include those people who can easily get another job? In other words, maybe the good people.
Right.
And so unless you really are confident that you're doing the best that you can with retention, you better not use retention as your indicator of whether or not somebody is actually a good performer, because otherwise you might just be learning a model of how to find those people who can't get any other job.
That's a great point.
Since we're on jobs, I was trying to track out here, because the selection bias, again, is sort of another issue that you brought up, right? But think about in getting a job, how crazy complex the selection bias is, right? So let's just say we're in this case where we're going to use the job performance, however we're going to measure it, and for now, forget about the things that you mentioned that are extremely important, like whether it's a toxic work environment for a certain class of employees, whether or not the proxy measure is actually really any good at judging whether you're doing a good job. Actually individual things like, does your boss liking you correlate with how good a rating you get, as opposed to whether you're actually doing a good job? Maybe it's if you make the boss look good is what you actually get good rating for. But let's forget about those. Who are these people that you're learning a model from? Because remember, if you're trying to figure out, how could I go out, because one of your initial slides was basically saying we can go out and we could find the best people at the beginning, right? Who is actually there in your employee base? These are the people that you're going to have values for this target variable on, right? These are the people that it is possible to create a training set with, are the people you already hired. That meant they would have had to have seen your job ad. That rules out like most of the population. Then decide to send you a resume, right? Then get invited for an interview. Then actually respond and then go to the interview, right? And then get through the interview, get offered a job, and then actually accept the offer and come on board, right? Right? How many different selection biases, sort of are involved with that? This idea that somehow we're going to correct the selection bias in there, I think, is a pipe dream. One thing that I wanted to do. I wanted to tell this Catherine Tucker's story from,
Yeah, that's great.
right.
Yeah.
So Catherine Tucker is a researcher at MIT, and she did a study that I love. It just got published in Management Science, if you're interested in reading that kind of thing. But let me tell you this. It's a real subtlety in the kind of stuff that Solon is presenting. This is not about jobs. So at a high level is this idea that, people get treated differently within these online systems. And so her topic was, it is about jobs, right? It's about, it was actually targeting ads for STEM jobs, science, technology, engineering and math. So there was a campaign done on, actually the results were replicated across, I think, 4 different of the major social networking systems. And so it's not, this isn't a indictment of any particular social networking system. And showed that these ads were shown 20% more to men than to women, even though they had explicitly said, we want this ad to be shown to men and women, right? And so, and particularly, it was not shown to women in the 25 to 54-year range, who, by the way, probably are the ones would be most advantaged by getting the jobs for the STEM ads, right? So, Catherine, and I should say, I forget now, Catherine may well have co-authors here. I think
it's someone at this university.
Yeah, yeah. So is Catherine's co-author in the audience? If so, I apologize for calling it Catherine's paper. Okay, so why? Why could this be? They say, show this to men and women. Put it out, let's call it Facebook. Put it out, and then Facebook actually, inside the internals of their system, actually ends up deciding whom to show the ad to. So one is, machine learning is learning to optimize the ad campaign, which it is learning to optimize the ad campaign, but it's learning to, so therefore, men must be clicking, or whatever they're using, clicking more on these ads than women. And so it just learns that men are better subjects for this ad. Turns out, no. Once you show the ad to women and men, the women actually click on it more. So even though the systems are learning these kinds of things, that's not the reason why. Okay, another reason. It learns from other sources. There's other sources from which it learns that men are better targets for these kinds of ads, right? So they do this study across a whole bunch of 90 countries, or I'm making up the number, but some large number of countries who have very different levels of all manner of different things, education for women, other sorts of opportunities for women, and they actually can control for these things and show that no, it does not seem to be, it's learning based that sort of men are somehow better for this job. So what's left? It turns out advertisers actually want to advertise to women, especially in this age range, more than anybody else. So this age range gets targeted explicitly by advertisers a lot more. So what happens? So the bid price goes way up. And so all else being equal, if you're actually optimizing for something like profitability of your campaign, and you don't specifically say, I want this subgroup, and that's an expensive subgroup, the optimization system will send the ads to cheaper places because it's trying to, the systems often are trying to get the number of clicks or conversions or whatever the outcome is per unit cost, and it can get them cheaper showing those ads to men than to women. How's that for complicated? And so when I think the lesson from that is that we can't really infer anything just from the disparate impact, right, without really kind of digging underneath the hood.
Yeah, so this has actually become like an interesting area for further investigation. I kind of like hand waved past it when I was talking. It's extremely interesting, and in fact, if anyone was following the news like 2 weeks ago, this HUD, this is the Housing and Urban Development, like federal regulator, just brought a case against Facebook that's pretty much exactly about this. All right, so there was a settlement, which was a kind of like a private cause of action, so like not the government itself bringing a case against Facebook. These were like people suing Facebook for allowing landlords and employers to explicitly target on the basis of things like race and gender, right? So they were using like the targeting tools to like specifically select, like only show to these people. The scenario that Foster is describing here is like the one where there hasn't been any attempt to select on that basis, but the simple fact of optimizing for engagement or click-through or whatever.
Per unit cost.
Per unit cost, yes. Has the effect of sort of shifting the distribution. And this HUD case actually is directly addressing this. So it's sort of saying that Facebook, not necessarily the advertisers, Facebook is potentially liable for disparate impact in this case because it is affirmatively contributing to shifting the particular population that is going to be exposed to these ads. Now, it's not saying this should be true of all ads. It's saying that for housing and employment, which fall under these particular regulations, then like Facebook actually should affirmatively prevent the distribution from ever shifting that dramatically, right? Even if the explanation happens to be because of the way that people are willing to bid to reach those different audiences. So it's sort of like almost irrelevant what the mechanism is that happens to explain the distribution in this case. It's just that there is this different distribution. It's a very interesting legal theory. It's not so clear what will happen. It's also a slightly weird case because HUD is on the one hand trying to undermine disparate impact as a doctrine, while on the other using it in this particular case. But anyway, just very quickly, like I think what's interesting about this to me is that, as you say, the mechanisms can be enormously complex. It's an interesting question when we care about the mechanism. I think we probably have an intellectual curiosity, what is the mechanism that explains this? But if all we care about is the disparate impact, we might not care what actually explains it. We each want to put the burden on the actor who's best positioned to deal with it, which probably is going to be like the network that is serving the ad. But I've had this kind of like thought experiment for the past couple of weeks, which is like, you know, advertising in general online is asserted to be like great because it's relevant. Like users want relevant ads. But thinking about these like expected value calculations and this kind of thing, it's like, oh, actually like relevant means something kind of peculiar here. Like it's not rank order per user what they would find individually most relevant. Right? This like the Tucker piece is saying like, no, actually women would be very interested in clicking on this. What they get exposed to is at least in part like influenced on purpose by how much people are willing to pay to reach them. And so like relevance here feels like slightly misleading way of putting the practice, right? Like we're not actually exposing users to the most relevant thing, even by our own model's calculation. We're exposing them to something that is being influenced by who's willing to pay the most to reach them. And it's just an interesting question whether or not we think that's okay.
Yeah. Well, in the online advertising industry, which I know a good bit about, you know, has been progressing from things like we're just going to try to find who clicks on the ad, right? Which, by the way, it's no good for anybody, you know, because nobody cares whether or not anybody clicks on an ad, right? And it ends up being so an argument could be made. Well, that's a good proxy for the people who might be interested in the product. It turns out it's not. It's a poor proxy for who's interested in the product. The people who click on the ad, like display ads I'm talking here, don't buy things, right? And they don't even look like the people who buy the people who click on an ad for a particular campaign don't even look like the people who buy. And so the industry has moved towards and gotten towards like conversions. So now we're going to find people who convert, right? But in fact, that's not what the brands want either. Right? If I just have had great machine learning algorithm, then I can find the people who are going to buy your product anyway, and target them, and I get lots of conversions, and I get no difference from what you would have done anyway, and you just spend all your money. It's not even good cost-adjusted outcome. Even if you found the cheap people who are already going to buy, right? I mean, it's better than finding expensive people who are, actually, no, it's no better in any way. It doesn't matter how much, if you're going to spend a particular budget, it doesn't matter though, right? And so really now we really have to get back to what we were talking about before and try to find a cost-effective way to find those people who would be most influenced by the ad, and that can be taken in a good way or a bad way. I want to actually call a stop to our kind of, to the stuff I have here on paper, right? And see if we've got some questions out there. And there are mic runners. Here comes one. Thank you very much for running mics.
Thank you. So I wanted to focus more on the optimistic side of things, because clearly you're showing that this, there is bias that's going to continue to sort of affect many of these different domains. I mean, are there examples that you can talk about areas, maybe outside of hiring, where I think it's very difficult, where machine learning has actually improved reaching targets and at the same time has reduced bias and allowed you to achieve, more diversity than, where human bias would predict it, through machine learning and that process, actually, you've achieved better outcomes. I mean, are there any areas where there's been research to say, hey, in this area, we have success?
Yeah, I mean, I think that's interesting. So a lot of this conversation happens without like a clear baseline of comparison. And I think if we were to kind of do careful studies of how well human decision-making is doing in a particular domain and then comparing it to how well some of these models are doing, I'd be surprised if we don't see like some improvement, both just in terms of like straight up accuracy and also reduction in bias. So I think despite all these concerns, it's very important that we actually have like some frame of reference. I think that the question here is like, is that always like the appropriate basis to say like we're making marginal improvements over human decision making and therefore we should be content? I think the hope is that we can do a lot better. So the work that people have begun to do in this area called sort of fairness in machine learning is trying to get a bunch of the good qualities you might already get from machine learning and then do some work to actually like address some of these concerns with bias, where you're like not only doing marginally better, but you're doing substantially better, and you've also explicitly tried to address some of these concerns. And I can say that like a lot of companies, small and big, have begun to try to adopt some of these techniques, and it will be very interesting in the next couple of years to see what that means in practice.
Yeah. I'm really glad you asked the question because, sort of looking in that mirror, right? I mean, it turns out that the academic world does tend to focus on all the potential problems, right? I actually think it's a good thing to reveal because guess what? There's no magic here, right? There's too much, sort of in the popular, thinking about how AI and machine learning is magic. No, it's just hard work, right? And there's all manner of different hard work. We talked about all the problem formulations, and this is one of the things that we should take into account, right? So I've, and again, I've been implementing machine learning systems for a long time, and yes, you see the systems do very much expand the populations that end up being affected by things. I think advertising is a really good example. The traditional way to do advertising would say, I know the demographic who's going to like my product, and so I'm going to advertise to that demographic, right? The behavioral-based targeting basically correlates 10 million different behavioral variables with the people who would buy the product, often initially through this kind of experimentation where they're randomly targeting people and then finding the people, right? And so you often see demographics that are not the chosen demographic. And actually sometimes you see whole populations that when you go and you examine them, you're like, oh, of course. They're using the product for maybe even for some unintended use, because they don't have anything to use it for. I may even be able to improve my campaign by specifically targeting them. What else do we have? And when we get the mic, there's another one up here. So, yes, please.
Hi, I have a question about model design and accountability. So specifically, I'm curious in cases where you're doing something sensitive like facial recognition, for example, and you might have a model that doesn't lend itself to being readily broken down, especially to a layperson or a lawyer, in terms of isolating a coefficient, like a neural net, for example. What is the opportunity or conversation to understand how those models interact with bias and to address that to the public?
Yeah, so this is something I've done a bit of work on, so let me comment on it. I think actually things like facial recognition are the most difficult problems. And the reason there is the factors that are used are, the factors themselves that get used are opaque. So the input data is just a set of pixel values from an image. And the deep learning systems that are now being used there sort of create the representation within themselves, right? And so there is work that then goes and tries to sort of show what's being done in there. Let me just broaden out the thing, because that's like the hardest thing, and so it gets really, really technical to explain that. But I think the answer to a lot of these things, I don't know, you didn't really have it at the end there. The answer is transparency. Right, the answer is being able to understand the reason. I mean, Solon knows that I have a particular view on this, right? Is to be able to understand the reasons why the machine learned model that's being used in practice, why it makes a certain decision, right? And for the cases where you can understand the input variables, everything we've been talking about so far, where you can understand the input variable, actually, it doesn't matter what the model is. It can be the most complicated and deep learning thing ever. There is an easy way to understand why it made the decisions that it did. And that's essentially we talked about the counterfactual and causal reasoning, try to ask what caused it to make the decision it did, and that would be something like what's the minimal change you can make to the input that would lead it not to have made that decision anymore on the output, right? And there's lots of different ways in which this can be used. And in my view, this is really the start of this isn't the answer in and of itself to any of these questions. It's the start to the answer to all the questions. If you don't, I mean, if you're basically saying, was that disparate impact or disparate treatment? You can't tell without saying, why did it make the decisions that it did? It might have race as a variable in there, right? And it didn't use it to make that decision, right? But it may have a proxy for race, that it did use in that, in making the decision. You have anything?
Yeah, no, it's a great question. I think it's sort of, in many cases, it's sort of assumed that when we have interpretability of some kind, whether it's like global model interpretability, so we purposely use like a very simple learning method, or we use the kind of method that Foster is describing, which helps us understand like what accounts for this particular classification, that those kinds of things allow us to then determine whether or not something is discriminatory or fair. But I think we have to be pretty careful about just assuming that like interpretability or even these kinds of like, this would be the minimum change you have to make, will always reveal unfairness, if there is some, right? In many cases, some of these measures that people have developed to just evaluate the model with respect to certain outcomes, given these other kind of features, can tell us much, much more about the model, at least with respect to fairness, than like interpretability count on its own. But as Foster says as well, there's like sort of the reverse possibility where like we actually might not know if something is really unfair unless we actually like, specifically understand the way the decision is being made. Right. So yeah.
Right. And so by the way, examining the coefficient, let's just say you have a linear model. Bear with me if this means nothing to you. You have a linear model. What is that? It's just a bunch of weights on a bunch of features, and you multiply the weights times the features, and you add them up. That gives you a score. You look to see if the score is above a threshold. That's actually the most common way that machine learning models make decisions. Okay. Despite everything you read about deep learning, no, really that's the way that most machine learning models make decisions, right? And so a lot of people say, well, then just look at the coefficients that have really high weights. Turns on, that actually doesn't tell you anything about the decision making of the model, because the decisions that are made by the models are a combination of the weights, which you can see in the model, and the data that comes in. And so if the data distribution that comes in, let's say you have a feature and it is race and has a super high weight on it. You say, oh, this model must be discriminatory. Maybe race isn't a good example for this. So some other variable that is just. The reason I say race isn't a good example is because race is going to always be present in one way or the other, in the example, right? But like some of these behavioral aspects that are very common now in modern machine learning systems, right? It may just be a behavior that nobody really ever does, right? It may really indicate what your race is if it does it, but basically 0.0001% of the data actually have a non-zero value for that indicator, right? And so just because You might say, yes, if someone happened to take that behavior, then the model is going to be discriminatory because we believe that to be an unfair proxy. But the fact is that it just pretty much nobody ever takes that behavior, right? And so we have to be careful even with simple models to sort of you can't just look at the model, you also have to look at the data distribution.
I think there was a...
Oh, yes, please.
So my question is a bit more of a technical one regarding the STEM example that you brought up. So I was thinking that isn't a lot of the ad placement, doesn't it depend highly on the search history? So there's a possibility that the samples were skewed in the beginning because, say, males search for STEM jobs more frequently because there's also a systematic underrepresentation of women in the STEM field in the first place, or was that taken care of in the paper?
In the particular Catherine Tucker paper example, in that case, I don't think so because it wasn't search. It wasn't a search engine ad. It was a social network ad.
Yes.
There could be some other factors, but the complication there is somehow or other the system would have had to recognize that it was a STEM ad. And I think the systems, I think, and again, I don't know this for sure, I think the systems aren't really doing estimations of that sophistication to sort of say, I come in with a new ad, and then, unless, it may say, oh, I'm Pottery Barn, and I'm going to use stuff I learned previously for Pottery Barn, but if you're coming in with a new ad, it's probably not.
I would take over. I would take over.
Yeah, all right, thank you.
Question for Solon.
My comment question is at a very low level compared to what's going on up there, but you mentioned authoritarian countries, and immediately came to mind a country that has very authoritarian and has a very high level of AI competency, in China, and where there's widespread use of biometric, whether it's facial recognition or behavioral and so forth. And I believe, you'll correct me if I'm wrong on this, they were asked if all of this machinery and cameras every place was effective in lowering the crime rate, and they said it was, yes, of course it is very effective, and they asked which of these different biometrics and monitoring pieces of equipment were the most effective and why, and the answer was, well, we don't really know that, we just know that everyone's scared to hell about them, and that's why it's effective. Not that they really are effective, but the perception is that they're going to get caught if they do anything. Yeah.
Actually, yeah, there's an article, which I haven't had a chance to read yet, I think over the weekend, specifically in the New York Times, specifically about China's use of facial recognition. So if you're interested in this, I suggest that you take a look at this. Maybe this is what you saw already. I mean, at least
Used essentially explicitly for discrimination.
That's right. So it was like specifically trying to infer the ethnic identity of people. But it has an intersection, at least in part, with business ethics, because increasingly, just as it was in the kind of early 2000s, a lot of the large tech companies are providing technology that could be used by authoritarian governments, and there's sort of questions about what should largely Western countries based in North America and Europe actually do when selling these kinds of goods and services to countries that have weak rule of law or whose political values just conflict with liberal democratic values. And so in the kind of early 2000s, this was sort of a question around, should there be censorship? Thanks. Should companies be willing to enter markets where they'll be compelled to censor things? And I think one of the newer versions of this debate is sort of should you be willing to sell some of this machine learning goods and services to countries that have different kinds of values? And I think it's a similar challenge. There are attempts to kind of have companies coordinate, even competitors try to talk to each other to better understand like what they should be doing or what they are doing in these kinds of markets. But it's a pretty serious business ethics question. Yeah.
So, I regret to say that we're out of time. This has nothing to do with my perceived inability to continue. So thank you very much for being here. Thank you very much, Solon.